Hello everyone. So in previous videos we have discussed about insertion in a linked list at the end, at the beginning, and now we are going towards insertion at specific position. We have already seen that insertion at the beginning, that means we are adding the node at the first node, making it a first node. Then insertion at end, that means making it as a last node. Now let us take an example where I want to insert a node that is at particular position. So this is my linked list and the first node is pointed by the head, that is my pointer variable. Let us have some value. Now what I want, that I want to add my new node. Let us say the value is 6 in between these two nodes, right? So this is my second node, this is my third node. So I want that this node will become the third node, right? So instead of, as of now we are having this link, right? This link indicates that the second node is having the address of this node, right? This node, it's holding the address of this node. Instead of this, what I want, that I need to have this link, that it should have the address of this new node, and this new node's link part should have the address of the next node, right? So once we establish this, then we are already we have done that insertion at beginning and end. So this is, after doing this, we are clear about how to insert a node at a specific position, right? So let's start with the algorithm. This graphically I have explained that instead of this, what we need to do, we need to break this link, and instead of this we need to create this link that I have shown with the orange color, right? So we'll go step by step. So step 1, as you all are aware of, that if you have gone through those two videos, so you might be aware of that the first step is always same, that we are inserting a node. That means first of all we need to do a memory allocation, right? So for that we can use malloc or calloc, right? So create a new node, and store address, right? Now we are storing at a address at a pointer variable called new node. So new node is equal to address of new node. So this is my pointer variable that I am using for access. Right now, next step, that means this my node has been created, right? But it is still a blank node, right? So step 2, what I need to do, I need to add the data, right? The information. So simply copy the information and data part, right? So how can we access the data part? Simply, that is with info of new node, right? So info of new node, that is equal to element. This element I can take statically, or I can take this as an input from the user, right? Now step 3, this, like after this, like this 6. So now I am having a node with a data part that contains the information parts, that contains the data 6. Still the link part is blank, right? In previous algorithm, we set the link part as null, right? At the insertion at the end. In the insertion at the beginning, we set the link part as a head, right? Now here we need to set the link part as the address of this, right? So first we need to traverse up to this position, because if we are not traversing up to this position, we would not be able to get the link, because the link of this part is available over here, right? So we need to traverse up to this, right? So for that again we need a traverser. I already discussed earlier with you the algorithm of traverser, how can we traverse, right? So here we need to traverse, so traverse up to position, right? So for that, first of all we need to initialize my current pointer. So current pointer is nothing but a pointer variable that we need to initialize with the first node. So I'm initializing it with the head, right? So my current pointer will start here, current pointer will start with this, right? Now I need to reach to this location, right? This particular location I need to reach, right? So first of all you need to take the position from the user, that at which position you want to insert a node, right? Once you are aware of it, that here in this case I want to add it to the third position, right? So I need to traverse up to the second position, n minus 1, right? So that's the thing you need to do. So the step 4, that move to position. So for that we just have a simple for loop, right? So we start with for I is equal to 1 to n minus 1. Now why n minus 1? That n, let us say that n is equal to 3. I want to add a new node at a third position. That means I need to traverse up to the second position, right? So for that I require that I is equal to 1 to n minus 1. If you want, you can if you are not comfortable with n, so you can have it position, right? So here you need to traverse I is equal to 1 to position minus 1. No difference in that, but position that makes sense, right? So you will get an idea, right? So along with that, this is one scenario, right? I is equal to 1 to position minus 1. Simple, we need to do that current pointer, we need to hop, right? So that's a current pointer is equal to length of current pointer. Now in this scenario that would be correct, because if we go for position is equal to 3, so it will check I is equal to 1. So 1 to position minus 1, right? So 1 is less than or equal to 3, 2, yes. 2 is less than or equal to 2, yes. So it will jump, and once it comes 3 is less than or equal to 2, then it will be out of this for loop, right? But what if that the position entered by the user, that is out of the scope, right? Out of the scope means here you have only like 1 2 3 4 nodes, right? And if the user enters that I want to add a node at a location 7, right, position 7, now in this scenario it won't be possible because my linked list end at 4th position. So we cannot have some garbage nodes inside that and feel that and we go for the 7th position. No, we can't do that, right? So for that, for this out of the scope, we need to have one more condition along with this. So there's a end condition along with this, that end current pointer is not equal to null. Now why this current pointer is not equal to null? Because you are hopping from first position to second position, second to third, third to fourth, right? Now if you go from fourth to the next one, the next position is what? Null. So it will go towards null. So if your linked list, all the nodes in the linked list are traversed and you are out of that, right, then your value of the current pointer will be null, right? So you are going to traverse up to for I is equal to 1 to position minus 1 and current pointer is not equal to null, right? Now this is a simple end of your if, right? So here this is your end of if, sorry, end of for loop, right? This is your end of for. Now if current pointer see in this, your current pointer will be out of this loop in two scenarios, right? One scenario, that is if the position is found, and the another scenario is if the number is out of bound, right? So first we need to check for the position, that whether the position is found or not, right? So here I am checking that position found or not. So for that scenario, what I need to do is that if I'm checking this condition, right, if due to this it is out of the for loop, so I need to check that if your current pointer is equal to null, that means you can say that this is that position given by the user that is out of range position, right? So you simply print position out of range, right? And then you can exit directly from here, right? No need to go ahead, because like suppose 7, so I user enter the data at the node at the 7th position, so that is not possible. So we can simply give a message to the user that whatever position you are trying to enter, that is out of the range, right? And in the else part, that if it is not like that, so that is my else part. Here I'll draw that again, that suppose we have this, right? This is my head, and here I want to add new node, right? So this is 3 2 1 5, and this one is 6, right? So I want to insert at this third position. So in a else part, that means what, that this is your step 7, that in a else part this would be entered at if the position is found. Previously if the position is out of range, this is for if position is found. So we need to set the pointers, right? So if position found, set link part, right? So we are setting the link part. So if the position is found, that means my current pointer is pointing here, right? Now what I need to do, that I need to break this, and this link part should have address of this, and this link part should have address of this, right? Now address of this is held by a pointer variable, that is new node, right? Now so here we simply say that link part of new node, that is equal to current pointer. But if we do so, so then what happened, this address, I want this address, right? Now this address of this node is holded by the link part of the current pointer, right? See, understand, this is my second node A, this is my node B, right? Here I want address of node B. Now address of node B is holded by this is what part, so that is link of new node, right? This is what I want to set, right? And that equal to what, I need to give address of this B node, right? But address of B node is available at the link part of A node, and A node is what, your current pointer. So that is equal to link of current pointer, right? Once you do this, that means what, this link is established, right? So now your A pointer is also pointing to B, and your new node is pointing to B also, right? Both node A and new node, both are pointing to node B. Now what I need to do, this is one link is done, right? Now I need to think about the another link. So another link is what, that in the address part, link part of A, I need to add the address of this third node, right? So the address of third node is available in my pointer variable new node, right? So simply I need to write that link of current pointer, that is equal to new node, right? And this is my end of if. Only these two settlements I need to do, right? What are those settlements? That this link and this link I need to set, right? And once this is done, this link is also set, right? And this is like, this one is removed, right? Now you can say that this is my first node, this would be my second node, this will work as a third node, fourth and fifth. So you have added your new node at the specific position. Here in this case this is 3, right? And the last check, that is exit or return, right? So it's a bit tricky but not complicated. It's very easy algorithm that if you are clear about the concept, you can easily write, right? So still, if you have any confusion, you can write it in a comment box, right? So this is about insertion in a linked list, inserting a node at a specific position, right? So thank you. I hope you understood it. Thank you very much.